Hi everyone. First, we would like to thank you for your interest in Automation Studio, the all-in-one, user-friendly circuit creation, simulation, and troubleshooting software for hydraulic, pneumatic, electrical, and PLC. In today's webinar, we will go over the electrical, AC/DC, and motor control module of Automation Studio. We'll go over basic manipulation. We'll create a basic resistive circuits. We'll change properties on some of the components. We'll insert measuring instrument. We will going to build a three-phase motor circuit. And then we'll also show you how we can actually put pictures on the schematic to make it look a lot more the real equipment. By creating customizable components, we can also actually create more like a wiring diagram by actually connecting real-looking components. We'll insert pictures beside the symbols that can actually be saved in a custom library. Therefore, you can create also a section in that library that will only have the components required to build that specific exercise. We'll show you how to insert a fault in your circuit. And also, we'll show you what's coming in the next version of Automation Studio. That's it for the quick introduction. So now we'll be in the software itself. So first of all, when you launch Automation Studio for the first time, it opens up with a white page, okay? This page is a document type that will allow you to put components from all the first libraries, hydraulic, pneumatic, electrical control, logic gates, PLC, all that, but will not allow you to drag a component from the Electrotechnical library. You see, for example, if I try to take one component, let's say like a DC source, you see it tells me I cannot do it, okay? So this is why you need to use a different type of document to work on the AC/DC motor control electricity, okay? That being said, some of you may use the electrical control library to make ladder diagram layouts, okay? Control circuit. Notes that in this library, we will not measure current, voltage, or anything like that. This is only for building a control circuit. Basically, like it could be your introduction to PLCs, you know, just making basic and or latching, unlatching, and things like that. Or if you want to do an electro-pneumatic or electro-hydraulic circuit, this would be the library that you could use, okay? I've had a discussion this morning with an instructor who actually wanted to put some problems on the circuit. Well, this is not where you're going to do it. You will use the Electrotechnical. So let's do a new diagram. So I'm right here. I'm going to go Document and go Electrotechnical Diagram. It asked me to choose from those. I always choose the default one because you can put both IEC or NEMA components. So it's going to load a page. This is my 8.5 by 11 page. So I'm going to show a couple of tips of manipulation of the software, okay, in a couple of minutes. So let me just zoom in here. And now on this page, if I try to take any other component from any other library than Electrotechnical, you'll see that this time it does not work. But if I go Electrotechnical and I take a DC source, now it works perfectly. Okay, so this is something that you need to be aware of. Sometimes technologies need a specific document type to be used. So let's build just the basic resistive circuit. So first of all, how the software works is you click on the component, you drag it on your screen. Once it's there, you can use the software. So I'm going to try to rotate this 90 degree because I want it to be the other way. So I can right click on it, go transformation, and rotate 90 degree like that. Or I could have select the component, go in the edit menu, position, and the same functions are here, okay? Now I'm going to drag and drop a resistor, sorry. Okay, like that here. And then I can put any value I want. By default, it's 1,000 ohm, 1 kilo ohm, okay? But if, for example, you double click on it, you can change the value of this resistor, okay? So let's say I'm going to put, for example, 200 ohm, okay? And then when I close, you see now it's 200 ohm. Then I'm going to take another resistor, so I can go in the library, drag it out again, or I can copy this one. If I want the value to remain the same, I can copy this one by simply right-clicking on it, copy, and then paste. Or it's Windows-based. I could have done here, Control-C, Control-V on my keyboard, does the same thing. Or if I hold the Control key down of my keyboard and I drag it, I'm automatically going to make a copy of it like that. Okay? So I want to put a couple of resistors in parallel this time. So I'm going to turn it. So right-click, transformation, 90 degree this way. Oh, sorry, I flipped it. 90 degree like that. Okay. And I'm going to flip it back so my port 1 is up there. So flip horizontally like that. I'm going to put another one here. So I'm going to hit the Control key and drag it here like that. Okay. Now let's change a bit of the value. So this one I'll say I'll put 220, 200. This one I'll put 470 ohm, for example. So click twice on it. Here, 470 ohm. Something important that you need to know. Okay. Once you're going to install the software for the first time, you're going to open this property window and you will see only the fields with a star on it. These are the most commonly used field. Okay. If you sometimes it was probably not as good as implemented as it should, so we're going to be updating that very shortly. But some of the fields may be important, they may be hidden here. So if you want to see all the fields, you click on the yellow star here to uncheck everything. And then you're going to see more parameters that display, like the tolerance, for example. You see, if I have only the favorite fields, I don't see it. But if I show all the fields, then it's here. Okay, so you can leave it like that, and then by default, if you're unchecked on this component, it will be unchecked for any other component that you'll use. Okay, you see how I put 470, so when I close it's like that. If I take a third one, but this one I want to be able to modify the value live during simulation. Okay, so I'm going to click twice on it. Let's say I want to leave it to 200, but I'm going to do here, I'm going to change the proper parameters control to be a slider instead of parameter. And you'll see what that's going to what that's going to be. Okay, if I close this, now let's connect these together. Something important to know when you make the connections. Okay, you need to click once, let go the button, and then you click again to make the connection. I'll tell you why the reason is. If I delete this, let's say if I want my line not to go straight from here, I want it to go a bit lower. So I'm going to click here, click here, click here, and click there. So if you keep your finger on it, obviously you can't make all those clicking like that. Okay? I'm going to connect this here. Then look what's going to happen when I'm going to click this one. If I click here once, I want to connect it here. But you see, I don't have a connection point, so I can't connect it. But if I double click, the software is going to make a junction. But this is electrical. I cannot really put a T in a wire, you know. I would have to do a splice or something like that, okay? So the software is asking me where I want to connect this. So to this port or this port. And if I choose this port, you see, though, if I click on the wire, it shows to me all the way where it goes. And this one, it also connects to this port, okay? If you don't want that, you really want to have like a T, and I'll show you why this could be good. Let me put one here. So I'm just going to search for splice. Okay, I can go here, expand the tree of the Electrotechnical, go for line, and then go to splice like that. Or I could have just typed here, let's say splice. And you see there it is. So I can take a junction like that, and then I can connect my wires like this. Okay. I'll show you what that does after. Okay. And then I'm going to connect this one here, not using the splice because I want to show you the difference. It could be confusing. You see all the wires? This one is connecting here. This one is connecting to somewhere else. So that's why the splice is good, because you know that these are all individual wire, okay? You see all those wire numbers I see everywhere. It could be confusing for the students, and you may not just want to get rid of those. So it's easy. You go into the View menu, and then you're going to uncheck the power wire, the common wire number. You don't want to see the ports on the components. You uncheck connection port names. Okay, so you can make it as clean as you want. Then once my circuit is done, I can directly start the simulation. But before that, I want to insert a measuring instrument. Okay, so I'm going to go here. I'm going to just erase my filter. So click here to clear the filter. Go in Electrotechnical section. Go to measuring instrument. And here we have all those measuring instruments that you can use. So voltmeter, amp meter, power factor, everything is there. So if I want to take, let's say, a voltmeter, and I want to show the voltage between that 200 ohms resistor, I can go like this. I can rotate this 90 degree, like this. And I'm going to put that on the other side here. And I'm just going to connect this in parallel with my resistor. Click here, click, click, click here, click, click. Now I want to show all my systems. So I can right click on the page and go zoom all components automatically. Or now I'm going to show you a couple of manipulation tools. If you want to zoom in and out, you can obviously do zoom all components, everything you see. But if you want to go zoom in something, maybe you have a bigger schematic and you want to focus on one point. If you hit the control key of your mouse and you roll the wheel on your mouse, you're going to zoom in and zoom out. And the zoom in and zoom out will go where you're pointing your mouse. So if I go like this, if I go like this, so you're really pointing where you want on your schematic. Now, you can also do it here, by the way, if you can adjust the plus, minus, but it will not focus where you're pointing your mouse. Then there's a panning feature, also very interesting. You can click here to move your document like that as you play with it. Or you hit the space bar of your keyboard and you move it. So space bar, click, and then you drag. You can move this around, okay? Now let's start the simulation. So you go in the simulation tab and you hit normal simulation. So we see we have 7 volt at that resistor, okay? There's different way of taking measurements. Let me zoom in one more time, okay. So by inserting a measuring instrument like that, you can also use these measuring instrument here, the dynamic one. So the one with the 2 nodes is for voltage. So let's say I click between this resistor like that, and it's going to show me 7 volt. Let's go if I go on the other one, the 470. So erase this, come here, and I'm going to put it up here instead. And then I'm going to show 7 volt. Okay? So you can go like this and measure through the schematic. If I go here, I'm going to have something different. The other ones are in parallel, this one's in serial, and I have 16.9 volt. Okay, so this is a way you can do it. And by the way, if you find that this is too big, while it's selected, you go into the Edit tab, and you just reduce the font size like that. And once it's placed, you can always click here and change its location to make it go wherever you want. Okay? The other way you can do it is using the measuring instrument. So if I go into the simulation tab, those you can only use them in simulation. So if you are in editing mode, they will be grayed out. Okay? So if I go multimeter, that shows up. I can go, let's say, voltage, and look where you need to place your probes. Okay? The probes, when you take them, they need to be dropped on a connection port. So you'll see when I get close to connection port, you see how it doubles up? There's a line around it. That means I can drop it. Let go of the mouse button. Then take the other one. Sorry, drop it. And there's my voltage. I can leave one probe there, move the other one, and there you go. Okay, so this is how you would use to measure the voltage. It's just making the probes go directly on the connection port. Let's say I want to measure the current in this circuit. Well, I need to open my circuit to use the multimeter. So I'm going to switch it to current. I'm going to click here, disconnect. This will give me a tool, a screwdriver like that. And if I click here, again on the connection port, you see click here, and then I click anywhere on the wire, it's going to disconnect this. But here's why I was telling you before that using the splice is good. Now you see I cannot disconnect this because there's too many wires here and I don't know which wire goes where, okay? So this is why, let me show you what happens when you use on the splice. If I come here, click here, click there, right away it works because there's only one wire, okay? So when you make connections, I recommend to use the splice because you make sure you only have one wire at each location. We know this is not the best, okay, but this is a way to go around it. We have discussions right now of maybe creating a new type of document which would be more called, let's say, electronics, in which we would not have this auto wire management, okay? This is done mainly because we have also the three-phase motor circuits, industrial control circuits, and for that, it's important for the people that will actually assemble the schematic that they know where this wire needs to be connected to which other component. That's why it's like that, okay? But rest assured, this will eventually be on a new type of document, but for now, if you use this, you will not have any problem. And it's like a bit of reality, you know, if you have like a breadboard, you have your resistors, you need to connect them together. So this is kind of a way of using it. Let's go now for current. So I'm going to actually take my probe, drop one here, and drop one here to see the current. But you see, my current, it's lower than what I have here. Okay? So I will need to actually use a different tool to measure that low current. Okay? So if I go, I can reconnect that. And if I go with this tool here, the one which is a component measuring instrument, I go here, I click on the line, it becomes purple. Then I drag, and then I let go, and I'm going to see the current, and I can choose how precise I want the reading to be. So you see, 35.9 milliamp. Okay, so this is how we can use the software by measuring. If you want to check the continuity or just measure resistor, no problem, you can disconnect the components. Again, you see there's multiple wires, so I can disconnect it here, okay? This is why the splice is very important, okay? So you see here, when there's only an empty dot, I know that this is only one wire connected. So if I want to measure this resistor, I would simulate. I can actually disconnect this here and this here. And if I go on, I can measure my resistor. Okay, so keep that in mind when you do a wiring diagram like this, to use the splice as much possible to avoid any issues. And it's same thing, you know, if like when we use the clamp meter like that, that's another one. If you want to measure the current in the line, you can position your cursor directly on the line and it will show like 50 milliampere, you know. It will show you the value where you go. But if you see here, I can't drop it, there's no red because there's multiple lines again. Okay, so keep that in mind. I just wanted to, I spent a bit of time on this, but I want to make sure because we've had question about that. My reading is not good, and this is sometimes the reason because there's more than one wire on the measuring. Okay, so this is what we can do. So here, let's say you see before when I put that resistor on the drawing, I put a slider to it. So if I click on it, you see I can then move to adjust the resistance to a you see the value here is way too big. So it's really hard to go from, let's say, a 200 to 1,000 ohm, let's say. So if you stop the simulation and you click on this resistor, you will see that there is a maximum resistance value. And right now it's set to 1000 kilo ohm. So what if I put, let's say, to this resistor to 400 ohm, and I'm going to say that the maximum that I want, maximum resistor, will be 500 ohms. Oh, let me just put ohms here and put 500 here. Now if I simulate again and I click on the resistor, you see I have much more flexibility now because I've set the maximum not being way too high like it was before, so I can get more precise. I can even put, let's say, a difference of 100 ohm if I want. It's really up to me to decide. So the maximum and the minimum values are important. Sometimes you may put like a capacitor and you want to put a value that the software will not allow you to do because it's kind of like a minimum. Then you need to adjust that so you can do it. For example, let's say if I take a capacitor, okay? Let's come here, basic and passive component, capacitor. Let's say I drop it on my screen, on my schematic here. You see right now, it's 4.7 microfarad, okay? If I click twice on it, you see the capacitor is 4.7 microfarad, but the minimum, the maximum here, okay, it's 100 microfarad. Let's say I want to make a 150 microfarad. You see, it went red because, and if you leave your cursor on it, it's going to say it needs to be lower or equal to 100 because this is what you have set here. So if you put here to 1,000 microfarad, then it's going to take you 150. Okay, so keep in mind sometime when you want to adjust something and it's not working, think about maybe looking at the minimum and the maximum setting. That may be the cause of the issue. Okay. I see that there's a question that was asked, sorry, but there's a lot of people connected to the webinar now. So what we're going to do is I'm going to answer the question at the end, okay? So just so we don't stop the presentation. So if you do have one, you can write it down, or after the presentation today, you will receive an email, and in that email, you will be pleased to hear your comments, suggestions, or any other topic you would like to get a presentation on, okay? So let's move on now from here. So we've done this. Um, Something that we also have coming soon in the next version 7 that will be released, like I said, this fall, is we've created a library of images, okay? Let me show you something. The library here, you see it's pretty, you need to navigate through it, control. You see when I told you to use a splice before, I had to go look for it, in the lines, splice and things like that. Maybe sometime at the beginning, you don't want your students to have the confusion of navigating through the library. So we give you the possibility to create your own library. Okay, so if, for example, I click on the first book in the library here, new library. Okay, let me just save that somewhere on my desktop here, training, electrical, electrical, and let's name it, let's say, simply electrical, okay? It could be your name, it could be the school name, up to you. Then in there, I'm going to create a section, a category, and I'm going to name this, let's say, DC electrical. And a subcategory to that, so while it is highlighted, I click again on the category, lab 1. And if this is my lab 1, I can drag and drop my components like that in the library. So all my properties that I've changed will be kept. You see that splice here? I can put it here instead. So students won't have to look for it. Okay? Same thing, the voltmeter, you can put it there if you want. So that makes it so much easier for students to do a lab with all the components already here. And you see the resistor here? I can rename this and add, if I want, 200 ohms. Oops, sorry, OHM. Okay, so I can rename it like that if I want, and then the student knows which one he's taking. Okay, we can also put pictures beside the component. Okay, so the way you can do that is very simple. There's two ways you can do that. Okay, is maybe let's say if I go on Google, okay, you may not want, this depends on, you don't want to take a picture that has copyright or things like that, okay? So, but just to show you something, 1000 ohms resistor, let's say if I go to image, let's say I find that this image is pretty cool. That's what I want to show the students. I can copy this image. I'm just going to go in paint first because it must have like a big white space around it when I paste. Yes, there is, okay? So I can just take a copy and paste of this like that. So copy here. I go directly in Automation Studio and I paste it here. So this is a 1000 ohm resistor. So I would probably change that to 1000 ohm just for the purpose of it, okay? So at least it matches. And then I can put that resistor like that above it, like this. I can select both elements, group them together, and drag this here as one component in my library. If I wanted to, I could have, let's ungroup this. Let's move that resistor. Let's copy this resistor over here. And let's say I can zoom in and I can put that resistor above the other one, just making sure I'm leaving the connection port visible. So I'm going to just here transformation, order, bring to front, and then I could just need to readjust. Okay, so when I move it, move like a big square at a time because we're on a grid. But if I go to home, I can take off the grid. For the drawing, I go here, no grid. And you see now I can move it very precisely where I want. I can put it here. I can group that together. And then the students actually feels like they're connecting real resistors. So this is how the library can be pretty cool because you can add images like that on the components itself, and then you can store it in your library and keep it like that. Okay. So what we've done also with that is that we've actually created a library of DC electrical component. Okay, this will be available in the next version, but this is just because we have a lot of people asking, okay, this is pretty cool, but we like to get them started with like the real images, real components. So if you go here in resistance, we have put a bunch of resistors with the color code already on them. So when you drag them out like that, the students actually work with the real color-coded resistor. Then we have a pot meter that you can bring out also. So when you simulate, you can actually adjust the resistor like that on the pot like this. So we have a couple of components with push button, switch, buzzer, LEDs, diodes, capacitors, polarized capacitors, photocell. The photocell, the same thing. If you bring it out like that, and when you go to simulation, you're actually hiding the photocell part, and that will change the resistors of the component. So we also have the batteries and power supply, AC, DC, different batteries like that. We have connectors. So you see here what we've done is because of the splice, we actually did add those splice in the library. So you see if I just take this and I rotate it like this, then I can use the splice like this. So I'm going to rotate this, let's say facing down, flip it like that. And then I can connect my components like this. And then I'll be able to take my measurement, and I'm sure I only have one wire between them. Okay, so we've done like a little splice, blue one, yellow, red, and we have some with the 4 connectors on it like that. Okay, so this library will be available with version 7. And we're going to, like in version 7, I'll show you later, but we're going to also have transistors. Now we have capacitors, inductors, LEDs, diodes, resistors. We're going to add transistors so that the transistors will also be added to this list now with the visual aspect of it. Okay, so this is something that whenever the version will be ready, we will let you know, and we can send you this custom library like that you can use and then make laboratories using real looking pictures, let's say. Okay, so now that we've done that, I'm going to actually build a three-phase motor circuit. Okay, so I'm just going to erase this. Let me just see if there's a question here that needs, well, okay, somebody asked a question. I'm just going to show you very quickly. You see when you had this and we had this, the person asked me, can I punch in the value? Yes, you can. You highlight this and you go 400. Or you can change that to 200. Okay? So when you remember when we had the first setting, it was like almost like to a million ohm or something. It was very hard to get precise. I could have also punched the value right there. Okay? So sorry, I just wanted to answer that question very quickly. So I'm going to erase that now. And then I'm going to go in electrical control and in my generic library. And I'm going to drag and drop, let's say, a three-phase source. Then I'm going to take, let's say, circuit breaker. I can give it a name. Just switch like that, doesn't matter. And I'm going to put the motor here. You see, by default, it displays those values. I don't really like those, so you can just click on it and delete, but I'm going to keep the speed. Okay. And then I'm going to put the wires. Okay. When you want to do the wires, you see here in the Ohm tab, we have common wire, power wire. So you can use those. So if you want a power wire, it's just going to make a thicker looking wire like this. Okay. You can go like this, one by one. We also have the polyphase wire. The polyphase wire, you can configure it here, what type of line you want to create. Let's say L1, L2, L3. And if you click here, you click once and it makes your three lines like that. Okay, so, but you can maybe ask the students to do one by one. And even if the students, let's say, don't pick the line, they're going to have by default the command line. They're going to go here. It's a thin line. They can always right click on the line and go here and go power wire. And it's going to get thicker. Okay. Again, if you don't want the power wire numbers to show, you go to the edit tab, to the view tab, sorry, and you say no power wire numbers and they go away. So now if I start simulation, I hit there, the motor spin. You see when I stop, you see how slowly it goes back? It's because there's no torque at all. So the inertia is like very big, so it's just gonna go and go and go. So what you can do is you can click on the motor and put a bit of torque on it. Oh, you see now? If I start, it goes out. When I stop, it almost stops suddenly like this. So you can adapt the torque to have a more realistic look if you want. Like now, if I just turn it on, turn off, you see it slows down a bit slower now. Okay, so this is my three-phase motor circuit. Now let's say I'm going to control this using a control logic circuit. So I'm going to move this a bit, and I'm going to use a transformer. Transformer here. Then I'm going to click this here. Again, you see I have to choose where it's going to go. So let's go there. You see I can right click to choose a power wire again. I'm going to connect this here to take two phase. Again, go to the left. And I'm going to change that to a power wire. So now I have 208 voltage coming in. If I click on my transformer, I have a primary voltage of 208 and a secondary voltage of 120. That's fine with me, okay? So then that's good. If I want to show it on the screen, click twice, you can check these boxes. To check it, you see, it's going to say value is displayed on the editor and the 120. So when I close, you see the values are here. I can just place them the way I want. And once they're placed, I can go here, change the font size, change the color of the text if I want. It's really up to you to do what you want over here, okay? And now I'm going to do a line here and a line like this. So basically what I want to do is I want to energize a contactor which will start the motor. So I'm going to come in the library. I'm going to go and take a 3-pole normally open. This is something important also. When you drag a component from the library, you can directly drop it on the lines like that and it will automatically disconnect the circuit. Okay? But you'll see what is going to happen. If I drop it here, it's going to disconnect and insert right away in the circuit. Okay? So now I'm going to use here a push button like this. And I'm going to name this, let's say, start. Then I want to energize a coil here like that. And I'm going to call this, let's say, a forward. As simple as that. And now I need to associate this with my forward. So if I click twice on it, I will filter here for F, and here's forward. Click twice on it, and now you see they have the same name. So if I start my simulation again, I come here, it energized, but the switch is not closed. So I'm going to close this, and then when I push, it energized. But every time I let go of the button, it turns it off. So I want to latch it, so I just need to drag and drop a normally open contact, let's say over here. I will connect this with the forward also. So this is my, I'm going to move it a bit. The components stay connected, so it's easy to realign the circuit the way you want. For example, if I want to move the start to the right. Okay, this happens sometimes. Okay, when you move components like that, it wants to reconnect wires to make sure it stays the same logic. Okay, so I just say don't show and I just do yes. Okay, that's all I do basically. So now I can readjust the line. I'm going to connect this over here. You see my line's a bit crooked here, but it's easy. I can just click on it and lift it like that. Okay, I want to take off this little piece here. It's confusing me for nothing. So now I'm going to have my forward that's going to be latched. Okay, but I want also to put a, let's say, a protection device on that. Or maybe a reverse. Let's put a reverse. So I'm going to move it a bit here. I'm going to take another 3-pole here. Zoom in. Let's go like that. And I'm going to connect this here. Again, I'm lazy, so I'm going to use a polyphase wire. So I'm going to do one by one. Let's say, come here, click here, come here, click here, come here. So that's the same. And now I'm going to have to exchange two phase to make it go the other way around. Like this. And now, let me zoom out a bit here. I'm going to take another line to actually activate my reverse. So I'm going to take normally a push button here, like this. I'm going to call it reverse. Oh, let's just name it PB1. Okay, if you want to change the name of a variable like that, I've assigned it the name, but I want to change it, I can simply delete and take another one. Or if you click twice on it, you can come here and edit directly here the alias, let's say PB2. Okay? Like I should have named the other one PB1, but let's take another coil here, and this one is going to be called reverse. So connect this like that. Like this. And this one's going to energize reverse. So I need to link this contactor's pole to reverse. Click twice. Filter for R, and here's reverse. Okay, so as you can see, it's pretty much the same way. You just drag and drop, you assign, you want to make a latching here, then you're going to say, okay, I want to put a normally closed contact of reverse because I don't want to be able to energize both at the same time. No problem. You simply go here, you take a normally closed contact like that, you drop it on the line, and then you call it, let's say you link that to reverse. Okay, so that's how easy it is to make your circuit like that in the software, okay? Let's say I want to add a protection device, an overload. I'm going to come here. I'm going to put an overload here. And I'm going to call it OL, okay? Then let's say I want my overload to cut everything here. So I can just put it like, I don't know where I want to put it. Let's say I'm going to put it here. I'm going to put it normally, so I'm going to go now look for it. So I'm going to go Electrotechnical, control. This is going to be a relay contact. And it's going to be a normally closed thermal overload. I'm going to drop it here. And it's asking me to which overload am I connected to. So I need to link it to OL. Filter here for O, and here's OL. Okay. The overload, what's fun about that is that you may want to be able to display the tripping time. So if you click twice on the overload, you see, if you go to the data here, you can decide to display the tripping countdown on your circuit. You see the 0 here. Then I may want to display what's my setting on my overload. So if you go to the builder here, you can set the tripping current. Let's say it's going to be 12 amp, like this. And then I approve and I close. I can display also the 12 amp like that on my drawing. So the 12 amp is here. I can place it just above like that. So now if I simulate, let's see what's going to happen. Okay. I'm just going to go forward. I'm going to click that down first. So it spins good, no problem. Then let's go in the simulation here and take a clamp meter to measure the current in one phase. In that phase, I have now 3 amps, no problem. But what if I click on my motor and I increase the torque on it, which will increase the current? If I go above 12 amp, you see my overload start counting down, 30 seconds. If I go higher than that, it's going to trip in 2 seconds, 1, 0, tripping this contact, stopping the motor. Okay, so we can actually show what's going to happen if, let's say, you can lose a phase if you want to, cause a problem like that. For example, this is also the troubleshooting. It's going to be, okay, the time is going very fast, so I'm just going to try to show you some things quickly here. But let's say I want this wire to be cut. That's going to be a problem that I want to do for my students. I click twice on this wire, and I can go in troubleshooting, and I can declare this wire to be cut, okay? And I can actually link this wire, this cutting feature, to a toggle switch. Let's say I'm going to call this fault 1, okay? Then I'm going to go into my HMI library here. I'm going to go into the control, go for switch. I'm going to take a toggle switch like that. It's way too big. So let me just shrink that a bit. And let's see if I double click on this, I'm going to be able to go into the internal links and find my fault 1. You see here? If I click twice on it, the link is made. Okay, but it doesn't display here. So you may want to name it like that if you want, because we don't necessarily want the students to see the name. Okay, but you can write it. It's up to you. So fault 1. Let me close this. So now if I launch a simulation again, okay, start this. Let me just put down the torque because it's going to blow up right away. Okay, now it's good. I can take my current on that phase, 532 amp, that's good. Now let's engage the fault. I cut the wire. I should have measured on the other wire. You see the current goes up, my motor is slowing down, and then my overloads start tripping because the current goes way up and then everything's going to stop. So then you can tell the students, okay, what's causing the problem? Why when I flip that fault, that behavior happens? So he needs to take measurements and figure out what the problem is. And like one of the instructors we work with, he's asking his students, because since we can go into tools here and record videos, he's asking his students to record themselves as they describe the error on the circuit, and then they send that to him, and he reviewed the video to make sure that they understood what they found as an error. So you can have up to 4 or 5 faults if you want, okay? And that will be something that you can do like this with having different cause problems with your circuit. Okay, so what I'm going to do now, because time is running out, I want to show you some demos. Okay, so let me just show you something. Imagine this circuit that you want to do it using real looking components. Okay, so we did for a school this year. I'm going to open a demo to show you. We took actual Schneider component. Okay, and we've created the custom component for him, and then he can use these components with his students to actually create like a wiring diagram, something like this basically. It'll look a lot different than what you do when you use the actual components, the symbols, but it works the same. If I start simulation, I can engage the motor spins, I can zoom in a bit, I can stop my overload, reset my overload, and start again. On this particular component here, let me just get rid of that multimedia clamp. He says that, okay, this one, there's something. You can activate the rotation, but he said that mechanically, you can't engage the other side. But I want my students to know that they've made an error in connecting the wiring diagram if they are able to energize both at the same time. So then if one is spinning and I energize this one, we're displaying an error like that. So that tells the students, okay, I did something wrong, because you need to use the contacts to make sure that you cut the other way before you can engage this one, okay? So this, we created a custom library, exactly like I showed you before. Let me open it here. And in that library, I've created the components. Let me just zoom in just so you see. Here we have push button with the same part number as Schneider has. Pilot lights, selector switches, contactors, overload, the motors. And after that, another school asked me for some relays. And then sensors. A sensor like this, for example, and then you connect to the real port numbers, and then when you simulate, you can just trigger the component like that, and then to show that it's activated. So when you have a need, I'm not telling you we'll do it and we'll be able to do it, but please let us know. Sometime we can help you by creating components like that. And you see the relays here, for example, I've just done a little circuit before today of just like a relay connection. It's called this relay with image, like that. So I have one side, the symbol circuit, and on the other side, I have the one using the relay. So you see they look a lot different, but if I simulate this, okay, I need to go get my 120 volt. And then when I push this button, I'm energizing the relay. And here, same thing, but you see it's not as cute, let's say, but it doesn't really show them how to wire up the components. And you see here, for example, I found this image online which display the ports, the contacts, but you can erase that. And the students just have this and they need to rely on information they'll find on Google, let's say. Go look at the specs. You may go in a company, you have to fix a machine. It doesn't mean that they're going to have the books very nicely placed beside the components. It's really rare. You're going to have to go and try to find the technical specs of that component to see how it works so you can troubleshoot it and make sure it's connected properly. Okay? So this type of things you can do by using the real components like that. Okay? So, and also I'm going to open the circuit just to show you, like, I didn't have much time, but we also have an oscilloscope that you can use. So let me open something here, that the circuit that uses like a full bridge rectifier. And this one has the oscilloscope connected to it. Okay, so you see my oscilloscope is here. When I start simulation, you see my probes are connected, so I can see the rectified wave. If I move my probe away, that goes away like this. And then we have the capability of having a ground per each channel or a generic ground for all the channels. It's really up to you to decide. And then obviously where you can move around the curve, in your oscilloscope like that without any problem. Okay, so this is something that you can also do using the oscilloscope. Okay, another presentation I wanted to show you was, hold on a second, uh, some switches, the PDT. There's a lot of things that we can do that we can show, okay, but keep in mind that we have a lot of different possibilities. We have capabilities of doing some circuits, and we can help, like here, it's just like a 555 timer in which we use the picture library that I showed you before, the DC library, and it just shows like a flashing light, okay? So when I simulate this, let me just move my plotter somewhere else. I can see on my plotter my simulation. And if I change the capacitor here, it's going to change the length of the flashing time. So I can go in my library if I want. I can go DC library, take a polarize, and this is like what? This is like a 22 farad, 22 microfarad, I think. Hold on. Yep. So let's say if I take a 100 microfarad, okay, I'm gonna disconnect this one, shift move to disconnect, rotate this 90 degree, and connect it here instead. And if I simulate again, you see that now the flashing time is much longer than the before because of the component change. Okay, so you could have done this using the symbols or with the picture. Sometimes it just makes it a bit more visual for the students. Now what's coming in version 7, I'm just going to show you something quickly here. Hold on a second. Let me just go here. Because some of you are power users, you've used this already, and then some people were having some demands, and so I want to show you what's coming in the next version. So first of all, we have improved the hertz. You can go up to 2000 hertz in version 7 because we have implemented new simulation pace. So before the highest one was like 1 microsecond, and now we can go up to 1 millisecond. Now we can go up to 1 microsecond, and that's enabling us to increase the hertz in the software. In the next version, like I was telling before, we will be adding transistors. Also, we're going to have the thyristor. Also, what we're going to have is solar panels and wind turbine. So we're going to have ambient temperature generator, a radiant generator, wind turbine generator, and then we're going to have sensors for those. So on the wind turbines, again, you'll be able to click twice and modify the properties. If I click twice on the wind turbine, you see we have the different calculation here that you can refer to. You can change all the different parameters that you need. And then we're going to have solar panel also. And same thing, you click on the solar panel, you can enter properties, you can define the angle of it, all those things, to try to make as accurate simulation as possible for those. Also, we're going to have the wind turbine, a bit same thing. So you can do a circuit like this with a gearbox, a generator, a load, and see the outcome of it by changing the wind speed. Something also, we're going to have implementing new batteries. Now we're going to have a DC source, but could act like a battery, so you can discharge it or recharge it with different type of batteries also. Okay, so that's why your input is always important because these modules are always evolving. Automation Studio is our only product, okay? So we do everything we can to make it as user-friendly as possible for customers. And when you have special needs, you send it to us. We cannot tell you when it's going to be done, but at least we'll let you know, okay, this might be done in the next version, in the next service release, and things like that, okay? But we always try to help as much as we can with the needs of the customers. Thank you very much again to everyone for being here today. If you have any other questions or comments, please don't hesitate to send us an email. You can visit our website at www.famictech.com/edu to access the educational portion of our website. So thanks again and have a great day.